All right, so let's check out some of the practice 5.1 and start with number one. So we have an angle of 148 degrees. And now, of course, you could probably just answer this straight off the bat, but I do want to try to be a little bit more active here with stuff and draw things out. So we're looking at 148 degrees. So this is 90. Going all the way across here is 180. So we know 148 is in quadrant 2. And so 180 here means it's going to be 32 away. And so it's going to look like that. And that is an obtuse. Now, of course, obtuse is between 90 and 180, so you could have just answered it like that. But I do want to try to draw some graphs out. So let's check out the next one. So we need to find the radian measure of the central angle of a circle of radius 30 inches. So let's draw this all out here. So we have a circle, and it has a radius of 30 inches. And the arc, so it says, where's my cursor here? It says arc of length. So I don't know why they have the word of there. So they're talking about arc length here. So they're saying we have some position, we rotate through to some other position, and they're telling us what S is. They're saying that this arc length is 140 inches. And so they're asking then, what is the radian measure of the central angle here? And so that's where we have the S equals R theta. So we know S is 140. We know R is 30. And so we're solving for theta. So we can just divide both sides to get a 14 over 3 is theta. And let's just see what MyMathLab wants. Let's type an integer or a simplified fraction. We have a simplified fraction here. And there's our answer. So we'll check out this next one here. Find the radian measure of the central angle, again, so just like the last problem. And an arc length. So again, we have a circle, and we have some radius that is 7 meters. And we're going to sweep through some angle. Unknown angle, but we know the distance we travel here, the arc length, is S. 1,500 centimeters. Uh-oh, being a little tricky there they are. So we have SR and theta, which means we can go right to the S equals R theta formula to get arc length. However, the book is giving us our arc length in centimeters and our radius in meters, and all the units have to be the same. So we need to convert these. It doesn't matter which you convert. So why don't we go with, so centimeters, divide that by 100, gets us 15 meters there. So 1,500 centimeters is 15 meters. We could have also done 7 meters is 700 centimeters. Could have done that. Doesn't matter. Now that our numbers are in the same units, we'll go ahead and plug them in then. And then we get our answer for theta. So let me ask this. 15 over 7. Where is that on a graph? It's another good thing to start thinking about here. So an angle of 15 over 7, what quadrant is that in? So you want to think about, first of all, 7 over 7 equals 1. That's 1 radian. 14 over 7 is 2 radians. And also remember that pi is about 3. So pi, an angle of pi is 180 degrees. That's about 3 radians. Now, 90 degrees is about 1.5 radians. So that means 15 over 7 then is somewhere here then in quadrant 2. So let's check out the next one here. Convert this angle in degrees to radians. So we're going to do some of the conversions then. So we have 144 degrees. Now remember, from the video, we have degrees, which means degrees goes in the denominator because we want degrees to divide out, which means then radians goes in the numerator. And then remember, pi always goes with radians, and 180 always goes with degrees. This is our conversion factor then. And so now the degrees will divide out, and we'll be left with then 144 pi over 180 radians. Now, of course, we do want to simplify this. And let's see. I mean, we can always, since they're both even, we can always just go the 2 route. And I guess we can keep dividing by 2 again here. And 36 and 45 actually has 9 in common. And there's our final answer. Now let's look at what MyMathLab wants. Simplify your answer. Always simplify your answer. Type an exact answer in terms of pi. So they want exactly 4/5 pi. They do not want the decimal. There we go. So let's check out this next one here. Convert the angle into radians. So again, we want to get rid of degrees. So that means degrees has to go in the denominator so that they divide out, which means then radians goes in the numerator. So now the degrees will divide out, and we're left with then minus 390 pi over 180. And then we'll do our best to simplify that. And if we can always do the straight divide out the 10 there. And 39 is a tough one. That's only going to be 3 and 13. So that, but 3 does go into 18 though. So 3 will go in here 13 times, and 3 will go in there 6 times. And by the way, it's all up to what you prefer. Notice how I'm writing it. I always like the minus sign before everything, and I always like my numbers together and letters kind of separate. But you know, you could also put it all together in the numerator, that all means the same thing, just different ways of writing the same stuff. Let's check out the next one. So now we have radians that we're going to convert to degrees. So 3 pi over 2. And now we are in radians here. So now we want to get rid of radians. So radians has to go in the denominator. So that divides out. And pi always goes with radians. And then we have 180 degrees in the numerator. So not only do radians cancel out, but the pi also cancels out. And so we're left with then 3 times 180 divided by 2. And this is then in degrees. So it's almost always easier to do division first because it makes numbers smaller. And 180 divided by 2 get us 90. And then 90 times 3 will get us 270. So a new angle, minus 9 pi radians. And now we want to get rid of the radians. So we'll have that in the denominator so it cancels out. And pi always goes with radians. And 180 always goes with degrees. So now the radians cancel. The pi also cancels here. And so we're just left with minus 9 times 180. And what does that get us? It'll get us a 0 to, lost my train of thought, there's 7, and a minus 1620. So minus 9 pi radians. How many revolutions is that? So minus, that means moving clockwise, rotating clockwise, minus. So here is one, this would be 2 pi. 1 revolution is 2 pi. We'll go another revolution, which is another 2 pi. So that's 4 pi. We'd have to go again to get another 2 pi. So that's 6 pi. And then again to get 8 pi. So this is 4 revolutions. That'll be 8 pi. And then we have 1 pi left over because it's actually minus 9 pi. So after we circle around 4 times, our last circling then will go just pi. And so we'll end our terminal line, will end here. And so what we're seeing is a straight angle. And by the way, just to connect some more things with the lecture video, minus 1620. So what I'm saying here, what I just kind of drew out in this picture, is minus 1620. This is coterminal with 180. So convert the angle to radians. We got minus 176. And we want to convert that to radians. So to get rid of degrees, that goes in the denominator. And then pi radians in the numerator, so the degrees will cancel. And so we're left with minus 176 pi over 180. It's now in radians. And they're really going to make us work on simplifying this one. And, when numbers get big like this, I just go for the good old, they're both even. So just go for the good old division by 2 here. And so we'd get 88 over 90. They're both even again, so we can go with another 2. Put a 44 and a 45. And 44 is not going to have any factors in common with 45, so this is then our simplified form. MyMathLab, changing things up a little bit on us here. Always important to read how MyMathLab wants the answer, because notice I assumed MyMathLab wanted the answer in terms of pi, because that's the way the last problem did it, and I just assumed the next problem would do it, but that's not the case. Now they're saying round to 2 decimal places. I will have to go get my calculator here and punch this into the calculator. Now, when you use your calculator, remember, we're in radians now, so you have to make absolutely sure your calculator is in radians and not degrees. If you're not familiar with that, try to find the mode, M-O-D-E, button on your calculator, press mode, search through that menu to where it says angle, and make sure that's selected as radians. So we got 44 times pi divided by 45. And then they want this number to 2 decimal places. And there's what my calculator's giving me. And that's what they wanted there. So always make sure to read what MyMathLab wants. Check out the next one. So we have find a positive angle that's less than 360. Let me just draw that out. So 360 means, now it's positive 360, so that means going counterclockwise. So we have to have something that's less than 1 full revolution, and it's coterminal with 550. So 550 degrees. You always want to ask yourself, if you're dealing with an angle, how can you break this down? So for instance, 360 is 1 revolution. So 550 is at least 1 revolution. And then what's left over here after 1 revolution, we'd have to figure out. So we'd have to take 550 and subtract off 360 to see what's left over after we do our 1 revolution. So that means 550 is 1 revolution plus another 190 degrees. So if we look at our graph here, we go 1 revolution and then another 190 degrees. And so that's going to be right past 180. So right here's our terminal. And this angle here would be 10 degrees from 180. Now, they want an angle that's less than 360 that's coterminal with 550. Well, what's coterminal with 550? 190. 550 is just 190 plus 1 revolution. Adding 1 revolution to your angle will always get you something that's coterminal. And there's our answer. So we get another coterminal question here. And see what the information is again. Find a positive angle that's less than 2 pi. So again, we have the same situation, less than 2 pi. 2 pi means a full revolution. That's 2 pi. And we have an angle that's 13 pi over 4. So again, you want to ask yourself, is there a full revolution in here? Remember, a full revolution is 2 pi. 2 pi, which is 8 pi over 4. So 13 pi over 4 we can write as 8 pi over 4 plus 5 pi over 4, where 8 pi over 4 is 1 revolution then. Now notice 5 pi over 4. 5 pi over 4 is 4 pi over 4 plus pi over 4. So this is a half revolution. So 1 pi is half revolution, 2 pi is a full revolution. So if we draw this angle out, we know there's 1 revolution. So actually I already drew 1 revolution there. And now we're going to go another half revolution. So that means to here. And then we go pi over 4. And there's our terminal in the third quadrant. So the question is then, okay, well, what is this angle then that just starts right from the initial and just goes directly to the terminal? What angle is that? Well, that's 5 pi over 4. So again, if you have an angle and you add 1 revolution to that, that will always be coterminal. So what they're doing is they're giving us very large angles, and so we subtract off 1 revolution, and then we're left with the smallest positive coterminal angle. And let me just read my math app. It says, type your answer in terms of pi. So there we go. They want it in terms of pi again. And there's our answer. All right, so we got, throwing a bigger number at us here. Let's see what we got. So again, find a positive angle less than 2 pi. So again, 2 pi is 1 revolution, so we have to find an angle that's less than 1 revolution. And they're giving us pi over 140. So we want a positive angle. Now pi, now there's a minus sign here. Now, of course, division by 140 is making this a small number, but it's minus, which means we're just going a little bit into the minus direction, and there's our terminal. So here is our angle. So if we want something that's coterminal, and it's positive, well, let's just ask then, what is the angle from the initial rotating counterclockwise to this terminal? Well, we know a full revolution is 2 pi, and we know this little chunk right here, this little angle, is minus pi over 140. So this angle here is 2 pi minus pi over 140. Because this little minus angle is the minus pi over 140 part. And we will have to gather like terms here, so we do need 140 as a common denominator. And then 2 times 140 will get us 280 pi minus pi all over 140. And so we get 279 pi over 140. And I'm just going to take a wild guess and say that those aren't simplified. Oh, those are already simplified. And let's just see if that's true. Are those simplified? They are. And then our last question here. So let's check this one out. Find the length of the arc. So we're talking about arc length here. S on a circle of radius r intercepted by a central angle. So what all that terminology means, we have a circle. There's some central angle. So that's what this is right here. This is the central angle. And here's the radius. And then this distance here, the arc length, is S. So that's what all that wording means there. And they want us to figure out S. Well, S is r times theta. And they're telling us that r is 14. And they're telling us the central angle is 40 degrees. Uh-oh. Can't have degrees in this formula. Radians is the more mathematical unit that's friendlier to math. And if you're going to enter a number into a math equation, you should really try to make it sure it's in radians. So we have degrees here, which means we need to convert this to radians. And so we'll have to do that. Now we want to get rid of degrees, so degrees goes in the denominator. So the degrees will cancel, and we'll be left with 40 pi over 180. And so we can just get a 10 to cancel out there. And we can also get a 2 to cancel out there to get 2 pi over 9. So what are we actually doing? Well, we're actually going to do then 14 times 2 pi over 9, because this is the correct angle in radians, which has to be the arc formula here. The arc length has to be in terms of radians. So we had to make the conversion here because MyMathLab gave us an angle. And so if we look at this then, we would have 28/9 pi. And looking back at MyMathLab, they do say type your answer in terms of pi. And that's what we'll do. And there is practice 5. Oh, I'm sorry. There is another question. Oh, now they want the answer rounded to 2 decimal places. All right. Well, I'll have to get my calculator out for that. Now remember, the test here is they're probably testing to see if you understand your calculator has to be in radians. It's probably why they're throwing this in there, to get you in that habit of checking what your units your calculator is in. So rounding this number to 2 decimal places is 9.77. And that officially completes practice 5.1.